Today we will be learning about nuclear chemistry. The first topic is types of radiation. There are 3 types of radiation: alpha, beta, gamma. Alpha particles have the least amount of energy, while gamma particles have the most. Alpha particles are positive, so they are attracted to negative fields. Beta particles are negative, so they attract to positive fields. Gamma radiation has no charge, so it is not affected. Alpha decay occurs when unstable isotopes try to stabilize by emitting an alpha particle. An alpha particle is made of 2 protons and 2 neutrons. There are 3 types of beta decay: beta emission, positron emission, and electron capture. The second topic is balanced nuclear equations. A balanced nuclear equation obeys the law of conservation of mass. The total reactant mass must equal the total product mass, and the total reactant charge must equal the total product charge. This is an example of alpha decay. We start out with polonium with the atomic number of 84, and then as it goes through alpha decay, it becomes an atomic number of 82, which goes to lead. This is an example of a beta decay called positron emission. As you can see, we start out with 8 as the atomic number, and as it goes through positron emission, it comes out with 7 as the atomic number, making it nitrogen. This is an example of beta emission. As you can see, we start out with 6 as the atomic number for carbon. As it goes through this decay, it adds 1 to make this atomic number 7. So then it becomes nitrogen. The third topic is half-lives. A half-life is an amount of time it takes for half of a sample to decay into new elements. There are 2 ways to solve for a half-life. The first one is you could use the formula y equals a times 1/2 to the x power. Or you could use logic. In the formula, the y stands for the final amount, the a stands for the starting amount, and the x stands for the number of half-lives. An example would be 10 grams decays over 12 years. If the half-life is 4 years, how much remains? An example would be 10 grams decays over 12 years. If the half-life is 4 years, how much remains? The way you would go about solving the equation is plugging in 10 for A because it is the starting amount. Then you would plug in 3 for X because you have to divide 12 years by 4 years to get the number of half-lives. So then you would go through and solve the equation and get 1.25 grams. Transmutation is the changing of an atom of one element into the atom of another element. For example, radioactive decay is natural transmutation. The final topic is fission and fusion. Fission is the breaking of neutrons into 2 smaller atoms called daughter products. Fission can release enormous amounts of energy. Fusion occurs when nuclei combine to form a nucleus of greater mass, which also releases huge amounts of energy. It has to have extremely high temperatures to occur. In summary, fission has a very heavy nucleus that splits into more stable nuclei of less mass. It can also result in chain reactions. Fusion has a lighter nuclei that combines to form a heavier nucleus. For a chain reaction, first, a neutron hits the nucleus of a uranium atom. The uranium nucleus splits or fissions, releasing heat and several more neutrons. The chain reaction begins. Those neutrons hit other uranium nuclei, causing them to fission, and so on, an exponential process. Thank you for watching my video on nuclear chemistry.